All right, we're about to begin molecular orbital theory, which is another bonding theory. But to make sense of that, we want to go back and talk a little bit about the quantum mechanical model of the atom. Okay, so if you remember when we were talking about the quantum mechanical model of the atom, we said that, of course, we have the nucleus, which is going to be a really small part of the atom. Right, and then quantum mechanical theory dealt with where do the electrons live. So around the nucleus, you have your 1s orbital, right? So that represents the first orbital, first principal energy level, and 2 electrons can live there, right? 1 up, 1 down. Then the next layer has a 2s orbital in it, and then 3 2p orbitals, right? And if you remember, those p orbitals have this shape to them, and there are 3 of them, right? And there are 3 p orbitals. Each one can have 2 electrons in it. Okay, so these funny little shapes that we have here, they're called atomic orbitals, right? And so that's what we think about when we think about one atom. Now that we're talking about covalent bonding, we're talking about 2 atoms sharing some electrons. And what that means is that these orbitals have to overlap. So where the orbitals overlap creates a new type of orbital that's going to be called a bonding orbital, right? So this is what orbital theory is. So if we look at the 2 types of molecular orbitals that can be made. The first one is called a sigma orbital. So it's associated with sigma bonds. These are formed between 2 orbitals when they overlap symmetrically around the bond axis. Okay, so what's a bond axis? Well, if you look at these 2 s orbitals that we have here, so this picture right here, let's imagine that these are 2 hydrogen atoms. Okay, so each hydrogen atom has 1 electron in an s orbital. Right, we know that the nuclei are in here too, and then compared to the space that the electrons occupy, the nuclei are very small, right? So if those are our 2 hydrogen atoms, in order for them to make a bond, they have to come close enough together so that these orbitals overlap. Okay. When the orbitals overlap, they form a new orbital that's called a sigma bonding orbital. The symbol for sigma looks like this. It's kind of like an O with a little line attached to it. Okay. So the nuclei of each hydrogen falls within this bonding orbital, right? And then the electrons that each of those atoms brought to the molecule now occupy this entire space, okay? So this new blob, this shape, is around what's called the bonding axis. Okay, this is the bonding axis on each of these. And it's a line that can be drawn to connect the nuclei of the 2 atoms that are being bonded. Okay, so this is a sigma bonding molecular orbital for a hydrogen molecule. We also can talk about making sigma bonding molecular orbital between 2 p orbitals. So let's think about a fluorine atom. Okay, a fluorine atom has its outermost electrons in p orbitals. Okay, so nuclei here, very small, right? So if these 2 fluorine atoms want to bond together, they have to come close enough so that those orbitals overlap. Okay, that creates a new shape that looks like this, and it's got these 2 little blobs in the end, okay? The 2 nuclei of your fluorine atoms are in here, okay? If each of them brought an electron, now the electron can be found within this blob. Because this blob is symmetrical around the bonding axis, this is considered a sigma bond. Okay, we're going to stop this one here, and you're going to go on to the next video.